Before we get to example 1, let's read what's above it. In the box on the top, it says the inverse of f of x equal b to the x is called a logarithmic function with base b denoted log base b of x. And that's exactly how I read it. You read it again, the log base b of x. Notice the base of your exponential function is b, the base of your log function is going to be the same thing. A logarithm with base e, or log base e, is what we call a natural logarithm and is denoted with ln instead of log base e. A logarithm with base 10, or log base 10, is called our common logarithm and is often written without a base. So you would just see the log, you would not see the base there. So it's understood if there's a log without a base that it's a base 10. It's understood when we use ln that the base is e. These are the two that you will find on your calculator. Now as we move to example 1, we're going to be going back and forth between log form and exponential form. In letter A, we have exponential form and we want to change it to log form. To do that, we'll start with the log. The base of my exponential function is 5, so the base of my log will also be 5, and that base is written as a subscript. We're taking the log base 5 of our number over here, which is 125, and it's equal to the exponent, which is x. One way to remember this is that logs are just exponents. Whatever you take a log of, you are finding the exponent. The right-hand side of a logarithm, again, is always an exponent. So bases stay the same. Your exponent is after the equal sign, and then this number comes in here. So what you're thinking really as you look at your log is 5 to what power is 125? In part B, we're going to go the other way. We are given log form, and we want to change it to exponential form. If we do that, the base of my log is 2, which means the base of my exponential function will be 2. My exponent of my log, remember the number on the right is always my exponent, so that 3 is up here, and that's equal to h. In letter C, now we're dealing with a base of e. Remember, a base of e, we do not write log base e, instead we write ln. So this we would say is the natural log of p, and that's equal to our exponent, which is 4. What some people will want to do, so if you think about it in another way, basically what this is the log base e of p equal to 4. But we don't use log base e. Instead of using the log base e, we use this ln. So this is the one we want, not this one. In letter D, we have log form. We have ln of 6 is equal to k. So that says the natural log of 6 equals k. Don't forget that this ln does have a base of e. If you want to write it in there for now as you're changing back and forth, it might be a good idea. But if you think about it, our base here is e, so the base of our exponential function has to be e. Our exponent is always the number to the right of the equal sign, so that's the k, and that's equal to 6. Here's the exponential form. And then in letter E, this is a case where we have a log without a base. If you notice, there's no subscript here. We just have the log of 15 equal to n. Well, if there's no base written in, you can assume that that's a base of 10. You can fill that 10 in if you want to, just so that you remember that it's there. But as we write it exponentially, our base is 10. We're raising it to the n, that exponent, and that's equal to 15. Underneath here is a try this. There are 2 questions that I'd like you to try on your own. Go ahead and pause it and unpause it when you're ready to check your answer. If you did 1 correctly, you should have gotten 9 raised to the m is equal to j. And if you did 2 correctly, you should have gotten the log base k of p is equal to 4. If you have questions on either one of these, please let me know.